In this video, we're going to look at determining the charge of an ion. So we mentioned in the last video that ions are charged particles. Ions form from the gaining or losing of electrons in order to achieve a full outer shell. So it's a case-by-case situation. We have to look at each individual element and see what does this element want to do to achieve that full outer shell. Would it be more likely to gain electrons or lose electrons? We're only concerned with the valence electrons, the outermost electrons, but sodium is a small atom, so we can look at all 11 electrons of sodium. Sometimes I like the orbital diagram, sometimes I like the electron configuration. The orbital diagram for the 11 sodium electrons would look like this. 1, 2, 3, 4, 5, 6, 7. We got to pair them for 8, 9, 10. Here's 11. If you like the electron configuration better, 1s2, 2s2, 2p6, 3s1. So the valence electrons are the electrons in the outermost energy level. The highest energy level is the third. There's one electron in the 3s. The rest of these orbitals in the third energy level are empty. We mentioned the octet rule in the last video, that atoms want to gain or lose electrons to achieve a full outer shell, which usually means 8 valence electrons. That's our goal. Sodium right now has 1 valence electron. Here's our 1 valence electron. So we have to make a decision. What's more likely? Should sodium lose that 1 electron? If he did, then the next outermost energy level would be the second. And the second is filled with 8. 2s2, 2p6. Okay, so that's one option. We could just lose that 3s electron. Or option 2, we could try to gain 7 more. Right now we have 1 valence electron, we want 8. So we say, which do you think is more likely to occur? Lose 1 or gain 7? And you're probably thinking right. Let's just lose 1. If we lose 1, we get rid of this guy. We get rid of this guy. Now our outermost shell is the second. And the second is filled with 8. Perfect. Stable. Okay, so now let's look at the changes that occur. The original sodium atom is number 11. So there's 11 protons. The protons are positive. And 11 electrons, which are obviously negative, for overall no charge. The sodium atom is neutral. When we form an ion, we're not changing the nucleus. So there are still 11 protons, which are still positive. However, we're down 1 electron. We lost 1. Now we only have 10. 10 negative electrons. So if we add this up, we have a charge of +1. The sodium ion is charged +1, but the sodium ion is more stable than the sodium atom. It's one of the reasons why sodium is highly reactive. All he has to do is lose 1 electron. That's not so bad. When these atoms gain or lose electrons, their electron structure will often look like a noble gas. So here, the element that normally has 10 electrons, element number 10, that's neon. It's like every other element is jealous of the noble gas electron structure because they have full outer shells and full orbitals. That's very stable. The sodium ion is like a sodium nucleus with the electron structure of neon. And so again, it's not like we're morphing into neon atoms. It's still element 11 with 11 protons, and that identifies the element. It's still sodium. It's just a charged version of sodium because we lost an electron. Now don't make this rookie mistake. Rookie mistake. People will say if you lose an electron, the charge is -1. It's like you subtract an electron, so the charge should be negative. You lose 2 electrons. You lose 2, the charge is -2. Wrong. Rookie mistake. Wrong. You have to think of this as a balance between the protons and the electrons. Anytime you're losing electrons, the charge will be overall positive. You don't have enough electrons to match up with the protons. So losing electrons, your charge is always, always, always positive. On the flip side, check out sodium's best friend, chlorine. Chlorine is element number 17. I guess that's not too crazy. I can handle 17 electrons. 1, 2, 3, 4, 5, 6, 7. I gotta pair them. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's the 17 electrons in chlorine. And again, if you like the electron configuration better, 1s2, 2s2, 2p6, 3s2, 3p5. Alright, so the valence electrons are the electrons in the outermost shell. The highest energy level filled is the third. The valence electrons are all the electrons in the third energy level. The 3s2 and the 3p5 for a total of 7. 7 valence electrons. And again, we could look at the orbital diagram and we find the same thing. Here are my valence electrons. There are 7 total. Okay, so again, we're looking for 8. 8 is the goal. We want to fill our orbitals. And so we have 2 options. Option 1, we could lose all 7. If we get rid of those 7 electrons in the third energy level, then the next energy level is the second, and the second would be filled with 8, kind of like sodium. But sodium only had 1 valence electron. Here we'd have to lose all 7, and they have to go somewhere. We'd have to find another atom, or maybe multiple atoms, that are willing to take those 7. So option 2 is just to gain 1. We already have 7, we're looking for 8. So you ask yourself, which seems like it would be easier? Lose 7 or just gain 1? And you'd probably be right. Let's just gain 1. If we could gain 1 electron, or here we'd gain 1 electron in this open spot, then our third energy level would be full. It would be full with 8. So in this case, chlorine is more likely to gain an electron. So we take inventory. Let's see what we got. The original chlorine atom was number 17, with 17 positive protons and 17 negative electrons for overall no charge. Atoms are neutral, but neutral does not always mean stable. Chlorine and all the halogens are highly reactive. All they got to do is gain 1 more electron and boom. The outer orbitals are filled. They're very stable as ions. So again, we still have the same number of protons. We're not touching the nucleus. The protons are still at 17, but we have an extra electron. So now we're at 18 negative electrons for an overall charge of -1. Okay, so again, we want to have an electron structure that looks like the noble gases. They have full orbitals and that's very stable. The element that normally has 18 electrons, that's argon. So we have a chlorine nucleus with an electron structure that looks very similar to argon. Overall charge -1. And so again, the rookie mistake is that people will say, if you gain electrons, that's like adding an electron, the charge should be +1. Wrong. Again, you have to think about it as a balance between the protons and the electrons. If you have extra electrons, you gained electrons, your charge will be overall negative.